No, super.
So today, again in this lecture, we are continuing with our previous discussion connected with investment analysis and portfolio management subject. In the previous lecture, we have learned how to calculate the value of X, which will help you to minimize the risk of the portfolio. That means you are mixing up two shares in such a manner that ultimately portfolio risk will be minimized. And this is the optimum combination of the two securities. The formula that we have developed is x is equal to sigma 2 square minus sigma 1 2 divided by sigma 1 square plus sigma 2 square minus 2 sigma 1 2. Now we are showing the application of this particular formula and we will show you how your results are improving. Here we have two securities A and B. Their returns are given. Also corresponding probabilities are given. First we will calculate return, expected return of security A and B. Then we will calculate expected risk of individual share A and B. Then for comparing we will calculate cofactor and which will show which one is individually better. The calculation is shown here. This particular statement is showing the expected return from A and B. We know that expected return is calculated by multiplying returns with probabilities and then adding the result. So expected return of A is 12.85 and expected return of B is 12.10. So return wise A is better than B. But only return is not sufficient for us. So we have to calculate the risk. Risk is the standard deviation of the return of the individual securities. The detailed process we know, actually we are calculating expected standard deviation, which is the root value of the expected variance. The calculation shows that risk of security is high than risk B. Security A is higher than security B. That means security A has high return as well as high risk. And security B has low return as well as low risk. So directly by comparing risk and return, we cannot conclude that whether security A is better than B or not. For that, we have to calculate the cofactor. If we calculate the cofactor, then we will observe that security A cofactor is 0.9919. That means against 1% risk, extra risk, our extra return is 0.99. But in case of security B, against 1% risk, the cofactor is saying that our return will be 1.0737. So 1.0737 is definitely greater than 0.9919. So if I decide to invest in only one share, then we will go for share B, where return is low as well as risk is low, and ultimately cofactors of the security B is higher than security A. So this is our decision if I decide to invest in only one security without developing a portfolio. Now, it has been stated that a portfolio we can develop by mixing 40% security A and 60% of security B. So now we are trying to develop the expected return and expected risk of the new portfolio. We know the formula of expected return and applying this formula, our portfolio return becomes 12.40%. Next calculation is portfolio risk. For that, we require the standard deviation of security AB, covariance, and the proportion of X, which is 0.4. So again, we will apply these results into the formula of portfolio risk, our result is 1.8240. Therefore, the new portfolio which has been developed has return of 12.40 and risk of 1.8240. So if I calculate cofactor, it is 6.798, which is much higher than cofactor of security B, which we have selected for investment. The security B, it was about 1.11, whereas it is 6.79. So there is a lot of improvement if we go for portfolio with 40-60 combination. So if the investor wants to know whether he will go for individual CIB or he will go for portfolio of 40-60 combination, the answer will be obviously he will go for 40-60 combination. But now the question is this 40-60 combination will give the best portfolio? Answer is may or may not. For that, we have to calculate the risk minimizing X value of portfolio, the formula for which we have developed in the last lecture. The formula is sigma 2 square minus sigma 1 2 by sigma 1 square plus sigma 2 square minus 2 sigma 1 2. We have already calculated the value of sigma 1 2 and sigma 1 2. In fact, here security 1 and 2 is replaced by security A and B. So, sigma A is 12.9552, sigma B is 11.2690, and sigma AB is minus 144.2551. The negative value of sigma AB indicates that two share A and B are diversified nature. Therefore, the investor will get a significant benefit from the portfolio through diversification. Now let us see what is the value of X. We have applied the numerical values in the formula and the figure is X equal to 0.4656. So this result is showing that instead of investing 40% in security A, we have to invest 46.56% in security B and balance 53.44% in security 46.56 in security A and balance 53.44% in security B. So that should be the optimum portfolio. Now we will justify whether this particular contention is correct or not. For that we are calculating yield and risk of the new optimum portfolio. The expected return here is 12.45 by using the same formula and portfolio risk is 0.9298. So if I calculate the cofactor of the new portfolio, it is 13.39. So note that here also we are getting significant benefit in comparison with the previous portfolio. In the previous portfolio, 6.798 was a cofactor. But the new portfolio that we have developed with the help of optimum mix up, it is 13.39. So we can conclude that if we develop a portfolio of 66.56% of security A, that will be the best one. In the next lecture, we will continue further.